Alrighty, so our next part of this unit is going to be starting some real geometric proofs. So far, you've only done algebraic proofs to help you get into the flow of how these work. So I'm going to go ahead and share my screen. I'm on the wrong one. Here we go. So here is our segment proofs. This is the top of your page. This is what you're going to be working on for this lesson. So we've already learned these properties of equality. So this right here is reference for what you've already done. These properties may only be used with equal signs. The properties of congruence below can be applied to statements with the congruence symbol. Okay, so what we're going to do is we're going to fill this out, and apparently I lost where I was filling this out from. I'm going to pull it back up. There we go. Okay, so with this, we have the congruent sign. Remember, congruent means that the lengths are equal, okay? So here we have the congruent sign. I need to change my pen. I'm just all sorts of doing exactly what I need to do here. There we go. Okay, so for any segment AB, we can say that AB, remember reflexive, let me come back up here and show you what it means for equality. Reflexive for equality means that this is equal to itself. Okay, so the same thing really applies for the reflexive property of congruence. We can say that AB is congruent to itself. Okay, symmetric property of congruence. Again, it's the same idea of the symmetric property of equality, where we said if A equals B, then B equals A. We write it backwards. We can do the same thing. We can say if AB is congruent to CD, then we can write this backwards. CD is congruent to AB. And you saw some examples where we did use that in the equality proofs. All right, and then the transitive property, it works the same way as before. If AB is congruent to CD and CD is congruent to EF, okay, then we can take out this middleman. That CD doesn't need to be there, and we can say that AB is actually also congruent to EF. Okay, so that's what those mean. You've used these a little bit with the algebraic proofs. We're going to continue to use those with congruence. Okay, remember that earlier I did say we have properties, definitions, postulates, and theorems that we can use as reasons in a two-column proof. So we're going to talk about two definitions that you're allowed to use. One is the definition of congruence. And this, by the way, this over here is what you're allowed to write in your reason column. Okay, so in a two-column proof, this is what goes in the second column if it applies. So here, definition of congruence. If AB is congruent to CD, then the measure of AB equals the measure of CD. Notice right here, we have the line symbols above it. That means we're talking about the actual line. If we're talking about it without the line symbols, we're talking about the measure. Okay? Same thing works the other way. We can also say if AB equals CD, those are the measures. So let's say that this is a triangle, and here we have A, B, C. I shouldn't have done that. I should have done with more letters, but we could say AB, okay, this line is congruent to BC, okay, or we can say that AB, which is 7, is the same as 7. So 7 would be the measure, and the line is the line. So it's a little confusing until you get the hang of it. We have AB equals CD is the same as AB being congruent to CD. Now, definition of a midpoint. We've talked about midpoints already a little bit. Whoops, stray line, because I was just marking all over the place. So midpoint of a segment divides the segment into two congruent parts of equal length. So if M is a midpoint of something like this, then we can say that AM equals MB, two equal parts. And down here we have the segment addition postulate. You learned this in the first unit. If we have something like this, A, B, and C are collinear, that means they are on the same line. Okay, and B is between A and C, then we can say AB plus BC equals AC. All right, so what you're going to do here is you're going to do a little bit of practice. Again, I'm going to do just a couple of these with you, and I want you to fill in the rests. This is a must-do assignment. Let me know when you're finished, and I will check them. So ones I want to do, I like number 2. So it says, if K is between J and L, then JK plus KL equals JL. So which one is that up here? Well, the only one that even has a plus sign in it is this segment addition postulate. And this does make sense for segment addition postulate. So that is what I'm going to choose. Segment addition postulate. And I'm just going to write post. Okay, with a little period after it. Okay, another one. Let's take a look. I kind of like this one because it's kind of weird because it has plus signs, but it's not the segment addition postulate. We have RS equals TU, and then we have RS plus XY equals TU plus XY. Well, what did they do to get from here to here? Is they added an XY to both sides. So that is the addition property. Okay. Let's choose another one. Let's do, let's do this bottom one. If RS equals ST and ST equals UV, then RS equals UV. So here we have taken out this middle guy and said that these equal each other. That is always going to be a sign of the transitive property. So there's a few for you. I want you to really think about what these are. You have down here a reasons bank. You're going to be able to use these on your proofs that you do. And it's nice to have those as an easy reference all on this page. So when you come back to the next video, we're going to talk about segment proofs, but I want you to practice with these properties first. Stop sharing, stop recording.